Milk Minute.
Gathering data has been the trend in almost all grounds of endeavor. These data are used to assess things about the nature of human beings, phenomena, and even our world. But in some instances, gathering data is almost impossible to happen because the population is too large. It would be extremely hard for the researchers to gather all the necessary data. That's why the use of random sampling takes place. It is used to get the appropriate statistic from the samples to draw conclusions that would represent the entire population. Sampling distribution shows all the possible samples in a given population together with their means. It explains the probability of the mean of all sets of samples with the same sample size n. The notion of sampling distribution eases us to recognize how we use one random sample to infer for the population. It is a significant idea in statistics, for it is considered the foundation and it is crucial to learn. That's why, in today's challenges and uncertainties, learning this concept is vital.
Senior High School on Air.
Senior High School on Air. The front line of quality and excellent learning.
Excellent learning. You have all the best of the best.
Best of the best of the best.
Magandang umaga, handa na ba kayong matuto?
Handa na po.
Reading and writing.
Pagbasa at pagsusuri ng teksto tungo sa pananaliksik.
Practical research 1.
English for academic and professional purposes.
Ability and statistics.
General biology 2.
Disciplines and ideas in applied social sciences.
Cookery and more.
Senior High School, best of the best.
Best of the best of the best.
Good day, my dear learners! We are here again for another timely and relevant episode. This is Dep at Radyo Eskwela, your school on air for statistics and probability. I am your radio teacher, Sir Jeremy Baliga.
Tayo na sa Radyo Eskwela. Tayo na!
Hello learners! I hope you're doing great today and always have the excitement to learn through this broadcast. Now, find a comfortable place. Make sure that you're holding the necessary things and let's all together learn the practicality of statistics and probability.
Halina't matuto gamit ang ating radyo. Pakinggan at unawain, aralin na ituturo. Patuloy ang edukasyon para sa ating henerasyon. Sa daan ng pagkatuto ay walang maiiwan. Kaya halina sa Radyo Eskwela.
Previously, you've learned about random sampling and its different types. We defined random sampling as a selection of the n elements derived from the n population, which is the subject of an investigation or experiment, where each point of the sample has equal chance of being selected using the appropriate sampling technique, which includes simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, and multi-stage sampling. These sampling techniques are used depending on the situation. You've also learned to distinguish between a parameter and a statistic. We define parameter as a descriptive population measure. It is a measure of the characteristics of the entire population based on all elements within the population, while statistic is the number that describes the sample. It can be calculated and observed directly. You can use sample statistics to draw certain conclusions about the entire population. Parameters and statistics are important for the determination of the sample size. It is important to know exactly what these measures mean and how to distinguish them. Last episode, you also had your quiz. Now, it's time to check your answers. For part 1, number 1, sample random sampling. I repeat, it is sample random sampling. For number 2, systematic random sampling. I'll repeat, it's systematic random sampling. For number 3, multi-stage random sampling. It's multi-stage random sampling. Now, let's proceed to number 4. The answer is cluster sampling. I'll repeat, cluster sampling. And for number 5, it is stratified sampling. Number 5 is stratified sampling. Now for the part 2 of our quiz last time, here are the answers. Number 6, true. I'll repeat, it's true. For number 7, the answer is true. Number 7 is true. For number 8, the answer is false. False is the answer for number 8. And for number 9, false is the answer. I'll repeat, number 9 is false. And for the last number, number 10, the answer is true. Again for number 10, the answer is true. I hope you got a perfect score or at least a passing score. We will continue our discussion after this infomercial.
Ilang buwan nang lumipas, 1,000 oras nakalipas. Akala ay natutulog, walang ginagawa sa sulok. Mga bata ay excited, kaya modalities ay implemented. Para proper education ay mag-get sa SDO Isabela. Walang batang maiiwan, we will learn as one, 'cause in education there is fun. Ang SDO Isabela ay handang-handa na sa edukasyon sa bagong normal. Handang isip, handa bukas. Isang paalala mula sa Kagawaran ng Edukasyon at ng himpilang ito.
And we are back on air, my dear senior high school learners. So for this episode, we are going to discuss sampling distribution of the sample mean. For purposes of statistical inference, a single sample is usually taken from a population, and appropriate statistics are computed from the sample. However, there are many different samples that can be formed, and the statistics computed from these samples may vary in value. Thus, we may regard each particular statistic as random variable whose range of values are the values of the statistics that can be computed from each possible sample. Consider this example. 5 packs of multicolored chocolate candies are known to contain 5, 8, 10, 6, and yellow-coated candies. These packs are placed in a bowl and 2 packs are drawn at random from bowl without replacement. How many possible samples can be drawn? Then, construct the sampling distribution of the sample mean. Okay, let's repeat. 5 packs of multicolored chocolate candies are known to contain 5, 8, 10, 6, and 4 yellow-coated candies. These packs are placed in a bowl and 2 packs are drawn at random from the bowl without replacement. How many possible samples can be drawn? Then, construct the sampling distribution of the sample mean. To determine how many possible samples can be drawn, use the formula the number of n objects taken from n at a time, where n is the total population and the small letter n is the sample to be taken out of the population. In this case, capital letter N is equal to 5 and the small letter n is equal to 2. Therefore, 5 objects taken 2 at a time is equal to 10. So, there are 10 possible samples to be drawn. The average number of yellow-colored candies in each sample can be computed. Now, let's identify the possible samples and their corresponding mean. Samples of size 2 are 4 and 5, with the mean 4.5. We have 4 and 6, with the mean 5. Then 4 and 8 with the mean 6. Then we have 4 and 10 with the mean 7. Then we have 5 and 6 with the mean 5.5. Then we have 5 and 8 with the mean 6.5. Then we have 5 and 10 with the mean 7.5. 6 and 8 with the mean of 7. 6 and 10 with the mean of 8. And 8 and 10 with the mean of 9. It can be observed that the sample mean varies from one sample to another. Since random sampling is used, then 10 samples have equal chances of being selected. Hence, we can regard the sample mean as a random variable. Let us now construct its probability distribution. All we need to do is to write the first means of the first row with the row tile X bar. Okay, write it now in your notebook. So we have 4.5, then 5, 5.5, then 6, then we have 6.5, then 7, 7.5, 8, and the last one, 9. I'll repeat, we have 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, and the last one, 9. Okay, so that's right. Next is, write the corresponding probabilities of the sample means on the second row with the row title as P of X bar. Okay, so we have the probabilities 0.1, 0.1, 0.1, 0.1, 0.1, another 0.1, and another 0.1. Then we have 0.2 because a mean of 7 appears twice. Then again, 0.1 and another 0.1. Since the sample mean can be treated as a random variable and its sampling distribution can be determined, it is possible to compute the mean, variance, and standard deviation of the sample mean. The standard deviation of the sample mean X bar is also known as the standard error of sample mean. This represents the average deviation of the sample mean X bar from the population mean MIU sub X. The smaller this error is, the better is the estimate provided by the sample statistic X bar of the population parameter MIU sub X, since it is guaranteed that the sample mean will not deviate much from the true population mean. We are now up to find the mean, variance, and the standard deviation of the sampling distribution of a mean. To find the mean, let's get the summation of the products of the sample means and their corresponding probabilities. In symbols, that is, E of X bar is equal to the summation of X bar times P of X bar. So we have 0.1 times 4.5 plus 5 plus 5.5 plus 6 plus 6.5 plus 7.5 plus 8 plus 9 times 0.2 times 7, which is equal to 6.6. I'll repeat, we have 0.1 times 4.5 plus 5 plus 5.5 plus 6 plus 6.5 plus 7.5 plus 8 plus 9 plus 0.2 times 7, which is equal to 6.6. Now, for the variance, we need to solve first for E of X bar squared, which can be computed using the formula E of X bar squared is equal to the summation of X bar squared times P of X bar. That is 0.1 times 4.5 square plus 5 square plus 6 square plus 6.5 square plus 7.5 square plus 8 square plus 9 square plus 0.2 times 7 square. I'll repeat, that is 0.1 times 4.5 square plus 5 square plus 6 square plus 6.5 square plus 7.5 square plus 8 square plus 9 square plus 0.2 times 7 square. That is equal to 45.3. Now, to solve for the variance of the sampling distribution of the sample mean, we can use the formula variance sub x bar is equal to E of x bar square minus E x bar square. By substitution, we have 45.3 minus 6.6 square, which is equal to 1.74. So, the variance equals to 1.74. Now, for the standard deviation, we just need to extract the square root of the variance. So, square root of 1.74 is approximately 1.32. At this point, let us also solve for the mean, variance, and standard deviation of the population for comparison purposes. The formula for the mean of the population is just the same with the formula of the mean of the sampling distribution of the sample means. We only replace x bar with x since we are talking about the population. So, the mean of the population is also 6.6. Now, for the variance, we need to solve for E of x squared. We also have the same formula. Only the replacement of x bar to x is different. Though we have the same formula, the variance of the population is not equal to the variance of the sampling distribution of the sample means. It's due to the fact that the 5 packs of multicolored chocolate candies were treated as a population. So the probabilities change. That becomes 1 over 5. So, E of x squared is equal to 1 over 5 times 4 square plus 5 square plus 6 square plus 8 square plus 10 square, which is equal to 48.2. Now, for the variance of the population, we have variance sub x is equal to E of x squared minus E of x squared, which is 48.2 minus 6.6 squared, which is equal to 4.64. Extracting its square root to get the standard deviation, we have approximately 2.15.
Tayo na sa Radyo Eskwela. Tayo na!
Based on the values we have solved, now we can make comparisons between the mean, variance, and standard deviation of sampling distributions of the sample means and the mean, variance, and standard deviation of the probability distribution or the population. First, the means are always equal. And second, the variance and standard deviation of the sampling distribution of the sample means are less than the mean and variance of the population. I'll repeat. The means are always equal, and second, the variance and standard deviation of the sampling distribution of the sample means are less than the mean and variance of the population. Alright, and that is for the mean, variance, and standard deviation of the sample distribution of the sample means. I hope you have followed me and able to master the competency. At this point, we are going to define sampling distribution of the sample mean for normal population when the variance is known or unknown. When the variance is known, 2 theorems will have used to define the sampling distribution of the sample means. Theorem 1, which is the sampling form of a normal population, says that suppose that a random population of size n is taken from normally distributed population with the mean and variance. If x bar is the sample mean, then the sampling distribution of the sample mean is a normal distribution with mean E of x bar is equal to mean bar is equal to mean, and variance is variance of x bar is equal to the variance sub x bar is equal to the variance sub x over n. From Theorem 1, we can make the following observations. First, since both x and x bar are normally distributed, the graphs of their distributions are both bell-shaped. And second, since ex bar is equal to mean sub x bar is equal to mean sub x, if the graphs of the distribution of x and the distribution of the sample mean are drawn to the same coordinate plane, the centers of the graphs, where the line of symmetry lies, will coincide. For the second theorem, which known as the central limit theorem, states that if a random sample of size n is drawn from a population with mean and variance, and n is chosen large enough, then the sampling distribution of the sample mean x bar is approximately normally distributed with the mean. E of x bar is equal to mean sub x bar is equal to mean sub x, and variance of x bar is equal to variance sub x bar is equal to variance sub x over n. This theorem says that regardless of the distribution of the population from which a sample is taken, we can choose a sufficiently large n so that the resulting sampling distribution of the sample mean will approach a normal distribution. In general, n is greater than or equal to 30 is large enough for the sampling distribution of the mean to be approximately normal. So, those are the theorem to be used as basis in defining when variance is known. However, in many cases, population standard deviation is unknown, or we can only obtain small sample size. When either of these cases occurs, we cannot use the normal distribution to compute probabilities for the sample mean. Instead, we use t-distribution or the student's t-distribution, which is distribution of the t-score. When the sample mean of size n is drawn from the population, the sample mean and the sample standard deviation s may be computed. The corresponding t-score or t-statistics can then be computed using the formula t is equal to x bar minus mean over s divided by square root of n, where x bar is the sample mean. Then we have the population mean, s is the sample standard deviation, and n is the sample size. The study of sampling distribution is essential in almost every field of study. That's why it is a must that as early as now, we should be familiar with this. To ensure retention, let's recall what we have been discussed today, especially the different formulae. For the mean of the sampling distribution of the sample means, we use the formula summation of x bar times p of x bar. For variance, it is variance sub x bar is equal to e of x bar square minus e x bar square. Extracting its square root would give us the standard deviation. We also arrived on two conclusions that the mean of the sampling distribution of the sample mean and the mean of the population are always equal. And second, the variance and standard deviation of the sampling distribution of the sample means are less than the mean and variance of the population. You've also learned theorems and definitions that define sampling distribution of the sample means when the variance is known and unknown. Theorem 1, which is the sampling from the normal population, and Theorem 2, which is the popularly known as the central limit theorem. The student's t-distribution was also discussed, which is used when the population variance is unknown. That's it for today's lesson in statistics and probability. Bear in mind those definitions and formulas, for they are vital in today's reality and can be used for future endeavors. Now learners, get ready for some drills right after this short break.
Taho! Taho kayo dyan! Di makatulog sa gabi sa kaiisip, damdamin ko'y mayroong lungkot hanggang sa panaginip. Oh, Berto, di ka ba nakatulog kagabi? Hindi nga ho, Kuya Pekto. Dala ho siguro ng lungkot ng pag-iisa dito sa bahay. Di ho kasi makalabas dahil sa COVID-19. Hay. Berto, may 3 bagay na dapat kang tandaan para maiwasan ng lungkot sa mga ganitong sitwasyon. Una, alamin ang dahilan ng iyong kalungkutan. Pangalawa, maaaring ipabatid ang iyong nararanasan sa mga taong malalapit sa iyo. Nariyan ang internet para makausap mo sila. At ang pangatlo, ilaan mo ang iyong oras sa mga bagay na ikaw ay magiging abala. Hindi lang pisikal na kalusugan ang mahalaga, Perto, pati pang kaisipan rin. Tatandaan ko yan, Kuya Pekto. Maraming salamat sa payo. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
For this episode's drill, suppose that the samples of size 2 in the example about multicolored chocolate candies are taken with replacement. That is, after drawing one pack of bowl and noting the number of yellow-colored candies from this pack, the pack is returned to the bowl and the second pack is drawn. List all the possible samples of size 2 and find the mean, variance, and standard deviation of the sampling distribution of the sample means. The packs of candies contain 5, 8, 10, 6, and 4 yellow-coated candies. I'll repeat. Suppose that the samples of size 2 in the example about multicolored chocolate candies are taken with replacement. That is, after drawing one pack from the bowl and noting the number of yellow-colored candies from this pack, the pack is returned to the bowl and the second pack is drawn. List all the possible samples of size 2 and find the mean, variance, and standard deviation of sampling distribution of the sample means. The packs of candies contain 5, 8, 10, 6, and 4 yellow-coated candies.
Halina't matuto gamit ang ating radyo. Pakinggan at unawain, aralin na ituturo. Patuloy ang edukasyon para sa ating henerasyon. Sa daan ng pagkatuto ay walang maiiwan. Kaya halina sa Radyo Eskwela.
And that is your drill for today. Answers will be revealed on the next episode. You may continue answering it even when the broadcast ends. And we are done with another episode. If you still have questions and clarifications, you're free to contact your teacher via text, email, or Facebook Messenger. Please don't forget to submit your learning activity sheet on the scheduled time at the drop box intended in your area. On behalf of our scriptwriter, Kesherwin Villa Korea of Cabanatuan National High School, and the whole SDO Isabela RBI production team, I am your radio teacher, Sir Jeremy Tamayo Hilbaliga, saying stay positive and test negative. Goodbye. God bless.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela.
Hi guys! Welcome back to my channel. So today guys, mag-makeup tayo ng bonggang-bongga para pretty tayo everyday. Yes! So una, dapat nakapag-moisturizer na kayo. The next is foundation na. Tapos itago natin ang bakas ng nakaraan. Mag-concealer tayo. Then iset na natin ang powder. Ayan! Huwag kalimutan ng eyeshadow. Tay? Wala naman ako ginagawang masama. Ano bang mali sa pagiging masaya? Sa kung sino at ano ako? Ha? Ano ba? Ang pagiging lesbian, gay, bisexual o transgender ay hindi sakit at hindi namamana. Kusa itong pinili ng tao na kabilang dito bilang parte ng kanyang oryentasyon at ekspresyon ng sarili. Huwag nating hayaang mabuhay at manatili sa takot ang mga batang ito. Lahat tayo, ano man ang kulay o kasarian, ay pantay-pantay. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
Tayo na sa Radyo Eskwela.
Tayo na!
Huwag mo nga akong maikiyakan dyan. Hindi ka artista para magdrama-drama ng ganyan. O ano naman ngayon kung binubuli ka sa school? Mahina ka kasi kaya ganyan. Yung mga pinsan mo ang tataas ng marka, tapos ikaw ano? Pumasok ka na doon at mag-aral ka na. Ang napabayaan at napahabang bullying ay maaaring maging sanhi ng depresyon. Ang mga usaping ito ay hindi biro at hindi pawang kaartehan lamang. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.